Okay, my name is Meng Wang. I have been at RPI since 2012. The courses I've taught include signals and systems, digital signal processing, electrical energy systems, and EP labs. As you could see from the courses I taught, my research interest actually mainly in machine learning, data analytics, and power system applications. I'm particularly interested in high-dimensional data analytics by using these intrinsic low-dimensional structures. A lot of data we collect from different engineering applications have strong correlations, and that correlation can be characterized by low-dimensional structures. And my research is to explore these low-dimensional structures to develop fast methods to recover the data, to correct the errors, and then to extract information from the data. And examples of the low-dimensional structures, like for example, for user ratings against movies, they are decided by a few number of dominant factors. Therefore, the rating matrix is low rank, even though the matrix is very high dimension. Another simple example is for images, like images we encounter and videos and images, they have a lot of correlation both across time and across space. Therefore, we can do image compression and image recovery. And similarly, in power systems, because the voltage and current are correlated through circuit laws, these quantities are highly correlated, and we could use that to recover the data and extract information. One example is this like image recovery. Suppose I have a video, but I have a lot of missing points and outliers, and how I'm going to recover the whole frame. So we've been working on that. We formulated as a matrix completion problem. We developed algorithms to recover the matrix, and then we implement it in different applications. Here is some like example of implementing our algorithm for recovering data. So as you could see for the left ones, original video contains many missing points and outliers, but on the right-hand side, we have correctly interpolated data. And this is a fundamental problem, and it actually can have applications in other domains, such as data recovery in power systems or like a data recovery of these rating matrices. So the method developed here can be also implemented in those domains as well. Another application problem we're interested in is about machine learning using neural networks. A basic example is like classification. Suppose I give you image, then by human, like you can easily see the image and then decide what type of image it is, right? Whether it's a cat, it's a dog, it's very clear to see. But for the machine, it doesn't have the eyes to, like it cannot make that decision. So the question we want to address is, can we design methods so that the machine, when it reads image, it can decide what type of image it is, whether it's a cat or whether it's a dog. And then nowadays people use neural networks. You can train classifier on neural networks. So the question we want to address is like what kind of methods to train these neural networks? Like how am I going to design the proper classifier for the machine so that when I have the image, the machine can tell me what type of image that is. And then after I train this model, I want to know like whether I would have the guarantee that this trained classifier can perform well on the testing data that I'm going to test. And then another question is, if I want to implement my method to train the data, how many training samples do I need so that I can know that the learned model, the learned classifier, actually going to perform well on the data. So these are the kind of questions we are addressing here. And for the opportunities of undergraduate research, particularly for undergraduate students, we hope that it could help us to implement and evaluate our developed methods. For example, my graduate students may develop algorithms for data recovery or information extraction, and we will need help in implementing them and then evaluate them on the testing data sets. And then the desired background for students will be knowledge of some programming language, either MATLAB, Python, or C#, depending on the platform we use. And they are also expected to be familiar with linear algebra so that they could understand and the algorithm we design. And for graduate level research, usually I look with students so that they can help me develop methods, machine learning methods to extract information, to design classifier, and so on and so forth. And I also expect them to be able to analyze the performance of their developed methods, such as like whether their algorithm can indeed perform well on this data set and why it performs well. And therefore, the training we provide to PhD students, in addition to the requirement for the undergraduate student, we also provide more advanced training on optimization, algorithm design, analysis, and also some training on the domain applications, for example, such power systems or image processing. So yeah, that's like a basic introduction to my research, and my contact information is on the first slide. Thank you.
Yeah, thank you very much.